Now I'm going to switch gears and talk about ionic compounds in terms of bond strength. And we're going to look at ionic bond strength, which we really measure as lattice energy. So remember, we talked about when we form these crystal lattices of ionic compounds that there is stability that comes from bringing all of these positive and negative charges together to arrange themselves in a way that maximizes their opposite charge interactions and minimizes their same charge repulsions. And so extra stability comes with the formation of that crystal lattice. And the name for it is the lattice energy. And I'll be honest with you, different textbooks talk about lattice energy with like a flipped sign. It's so just pay attention if you're going with resources outside of our textbook, how they're talking about it. And really what this is looking at is it's saying, well, what is the amount of energy that's released when we take all of these ions that are separated and bring them close together? And what is happening is we're taking a lot of ions that are now attracted to each other through its opposite charges. It's being balanced by some repulsions of the like charges, but overall we see a positive lattice energy, or we see energy released as an exothermic process as we form that lattice. And so some of the things that we can see, we can correlate this lattice energy with ionic bond strength. And we see some patterns emerge here, just like we did with covalent compounds. And I've got some examples here of a metal with a chloride anion and the lattice energy that we have. And so we can see as we go down here, the thing that's changing, we're going from lithium to sodium to potassium to cesium, is that we are as we're seeing that lattice energy get smaller or less negative, right? So less energy is being released as the lattice formed as we go down this series. And what this series is representing is size. And so we're seeing an increase in cation size correlate with a decrease in the amount of energy released as the lattice forms, which means that it is a weaker bond. And so the closer these get together, the stronger the ionic bond. And so that means that ion size is going to play a huge role in ionic bond strength. Cool. And the other piece that increases the bond strength between our ions is the magnitude of the charge. And so while it's important to get these ions as close to each other as possible to maximize those attractive forces, we also see that a larger charge is going to correspond to a stronger attraction. And that stronger attraction leads to a larger lattice energy, or more energy is released when that lattice forms. So the smaller the ions and the higher charge they have. So like a +3 is a much higher magnitude of charge than a +1. That's going to increase the strength of the lattice energy, or the bond strength between those ions. So very small +3, -3 ions that are coming together are going to be very strongly bonded to one another in an ionic bond. Whereas large +1, -1 ions coming together will be a much weaker ionic bond.